Welcome to G Fun Facts Online. Today we're tackling a question straight out of science fiction. Can humanity deliberately engineer a cooler planet? As the climate crisis deepens, a controversial set of technologies called geoengineering is moving from the fringe to the forefront of scientific debate. We're talking about taking control of the planet's thermostat. So, should we and could we? Let's dive in. Geoengineering proposals are generally split into two big categories. The first is solar radiation management, or SRM. Think of it as a planetary sunshade. It's designed to cool the Earth by reflecting a tiny fraction of incoming sunlight back into space. It's a bit like a temporary band-aid. It doesn't fix the root cause, greenhouse gases, but it might buy us some precious time. The second category is greenhouse gas removal, or GGR. This is the opposite approach. It's a carbon sponge designed to tackle the problem at its source by pulling CO2 directly out of the atmosphere. Let's start with the most audacious and controversial idea: solar radiation management. The most talked about method here is stratospheric aerosol injection, or SAI. The idea is to mimic the cooling effect of massive volcanic eruptions. When a volcano like Mount Pinatubo erupted in 1991, it shot millions of tons of sulfur dioxide into the stratosphere, that upper layer of our atmosphere about 15 to 25 kilometers up. These particles formed a reflective haze that cooled the entire planet by about half a degree Celsius for over a year. SAI proposes we do this deliberately, using high-altitude aircraft or balloons to release tiny reflective particles, like sulfates, into the stratosphere where they would remain for a year or two, scattering sunlight back into space. The main appeal? It could be fast and relatively cheap. Proponents argue it could be an emergency brake to stop us from crossing catastrophic climate tipping points, like the collapse of major ice sheets. But the risks are terrifyingly large. For one, using sulfate aerosols could damage the ozone layer. More importantly, it could create massive, unpredictable shifts in global weather patterns. While it might bring rain to one region, it could cause devastating drought in another, affecting food and water for billions. Then there's the termination shock. If we ever started a large-scale SAI program and then had to stop it suddenly, due to war, economic collapse, or a technical failure, the planet would experience a terrifyingly rapid warming as the climate snaps back to the level of greenhouse gases we'd been masking. This could be far worse than gradual warming. Research here is highly controversial. A Harvard project called SCOPEX was effectively halted by opposition. More alarmingly, a startup called Make Sunsets has claimed to be releasing reflective particles on its own, a move widely condemned by scientists for its lack of oversight. A slightly less globally impactful idea is Marine Cloud Brightening, or MCB. The goal here is to make existing clouds over the ocean whiter and more reflective. It's based on a principle called the Toomey effect. For a given amount of water in a cloud, having more, smaller droplets increases the surface area, making the cloud brighter. The plan is to have a fleet of ships spray a fine mist of seawater into the air. The salt crystals would act as new seeds, or cloud condensation nuclei, for smaller water droplets to form around. The potential benefit is that this could be done locally. You could, for example, try to brighten clouds over the Great Barrier Reef to shade the coral and prevent bleaching. The effects would also be short-lived, stop spraying, and the clouds return to normal. But again, the risks are huge. Cloud physics is incredibly complex. Injecting the wrong size or number of particles could accidentally make clouds dissipate, causing warming instead of cooling. And even a regional intervention could have global consequences. One 2024 study warned that brightening clouds off the US West Coast could inadvertently raise temperatures in Europe. The last major SRM idea is cirrus cloud thinning. This one is different. High, wispy cirrus clouds actually have a net warming effect. They let sunlight in but trap heat trying to escape. The idea is to seed these clouds with particles that cause them to form fewer, larger ice crystals. These larger crystals would fall faster, thinning the clouds and allowing more heat to escape into space. This is the least understood of all the techniques. Get it wrong, and you could accidentally thicken the clouds, causing even more warming. The uncertainties are so great that the IPCC has expressed very low confidence in it. So if SRM is a risky planetary painkiller, what about tackling the disease itself? This brings us to greenhouse gas removal, or GGR, technologies. The IPCC has made it clear that to limit warming to 1.5 degrees Celsius, some form of GGR will almost certainly be necessary. One of the most prominent GGR methods is direct air capture, or DAC. These are essentially giant air purifiers for the planet. Massive fans pull air through a system where chemical filters grab onto CO2 molecules. The captured CO2 is then released and can be permanently stored deep underground or used to make products like synthetic fuels. A Swiss company called Climeworks already operates a commercial plant in Iceland called Orca, which captures CO2 and injects it into volcanic basalt rock, where it mineralizes and turns to stone. The big advantage of DAC is that plants can be built anywhere, ideally next to renewable energy sources and geological storage sites. The downside? It's incredibly expensive and energy-hungry. Because CO2 is so dilute in our atmosphere, about 0.04%, filtering it out is tough. Current costs are around $600 to $1,000 per ton, though this is expected to fall. To be truly carbon negative, these plants must be powered by clean energy. Next, we have enhanced weathering. This method speeds up a natural process that has regulated Earth's climate for millions of years. When rain, which is slightly acidic from dissolved CO2, falls on certain types of rocks, it triggers a chemical reaction that pulls CO2 out of the air and eventually stores it in the ocean as stable bicarbonate ions. Enhanced weathering proposes to accelerate this by mining and crushing silicate rocks like basalt into a fine powder, then spreading it on agricultural land. The huge surface area of the powder and the microbes in the soil dramatically speed up the reaction. The benefits are compelling. The carbon removal is effectively permanent. The rock dust can also act as a fertilizer, releasing nutrients that improve soil health and boost crop yields. Field trials have shown this works. But the energy needed to mine, grind, and transport millions of tons of rock is a major hurdle. There's also a risk that trace heavy metals in the rocks could build up in soils and waterways. Another GGR approach is bioenergy with carbon capture and storage, or BECCS. The process is simple in theory. You grow plants or trees which absorb CO2. Then you burn that biomass to generate energy, capture the CO2 that's released, and bury it deep underground. Since the plants pulled the carbon from the air to begin with, the result is negative emissions. It's the only GGR technique that also produces energy. The problem is scale. To make a real dent in our emissions, BECCS would require vast areas of land that might otherwise be used for growing food or preserving natural ecosystems. It could lead to deforestation, biodiversity loss, and competition over water resources. Finally, there's the highly controversial idea of ocean fertilization. The plan is to add iron to parts of the ocean that have other nutrients but lack this key micronutrient. This would trigger enormous blooms of phytoplankton, microscopic marine plants. As they grow, they absorb CO2. When they die, some of them sink to the deep ocean, taking that carbon with them for centuries. While it sounds promising and potentially cheap, the ecological risks are immense. It could fundamentally alter marine food webs, trigger harmful algal blooms like red tides, and create vast dead zones by using up all the oxygen in the water as the blooms decompose. Because of these risks, there's a de facto international moratorium on large-scale ocean fertilization projects. All these technologies, from sunshades to carbon sponges, raise a huge question that goes beyond science: the ethics. This is the elephant in the room. The biggest concern is the moral hazard. This is the fear that the mere promise of a future technological fix will give governments and industries a license to delay the hard work of cutting emissions right now. Why stop polluting if we think we can just clean it up or mask it later? Then there's the governance nightmare. Who gets to decide to deploy a technology that affects the entire planet? What if one country's SAI program causes a drought that cripples another country's agriculture? Who is liable? There is currently no international law to manage this, creating a dangerous risk that a single nation or a coalition could act unilaterally, potentially triggering geopolitical conflict. Finally, there's the simple gut-level feeling that this is messing with nature on a scale we've never seen before. Public trust is low, and the fear of unintended, irreversible consequences is very high. So, where does that leave us? Geoengineering is not a silver bullet. It's a collection of high-stakes gambits, each with immense risks. The scientific consensus is clear. The first, second, and third priority must be the rapid, drastic reduction of greenhouse gas emissions. That is the only true solution. However, as the climate crisis worsens, there's a growing argument that we need to at least understand all the tools in the toolbox, even the riskiest ones. This means we need a transparent, international research program to reduce the scientific uncertainties. But more than that, we need a global conversation about the ethics and governance. Any decision to intentionally alter our planet's climate is a responsibility of planetary proportions. It's a choice that affects every living thing, and it must be approached with extreme caution, humility, and a profound sense of our shared future. Thanks for tuning in to G Fun Facts Online.